Okay, everyone, let us now proceed to the ellipse, another type of a conic section. So how do we define an ellipse? So an ellipse is the locus of points where the sum of the distances from two fixed points called the foci are constant. So what does that mean? So let's say, for example, we have an ellipse here in our illustration, right? So the foci here, as you can see, so this one focus right here, one focus right there. So the plural for focus is foci. So we have um, two, so we call them foci. Okay, very awesome. Okay, so if we select any point on the ellipse, let's say we have this point right here, and if we connect them to the one focus and to the other focus, now this distance right here, the sum of these two distances will be the same all throughout the ellipse for any point on the ellipse. Okay, so if we select another point here, so the distance will be the same, and the point here, so distance will be the same. So any point in the ellipse. So that is basically how you define an ellipse. Now it's time for us to learn the different parts of the ellipse. So as you can see right here, this encircled one right here is called the major axis. So if you take a look at the ellipse closely, we have two axes here. The longer axis right here is called the major axis, and then this shorter one is the minor axis. Okay, so and as you can see, the major axis has a length of 2a. You can see, right, negative a and positive a, and for the minor axis, that's 2b. So therefore, this half one right here, which we call the half of this, for example, the half of this minor axis is called the semi-minor axis. We call that b, right? B, and then for the semi-major axis, which is a. Okay, so we call this a. Now, in case you're wondering, so what is the length? What is the constant length that we were talking about earlier? So we say that this is the constant length, right? So what is this? What is this length actually? So can we find it in terms of a or b? So actually, yes, we can. So if we move this point, if we select, let's say, a point right here. Oh, this is another part of the ellipse. This is called the vertex. Okay, we have two vertices here. We have one vertex on the right in this case, and another one on the left. Okay, negative a0. Okay, so let's say if a point, say we go to the vertex. A vertex is still another point on the ellipse, right? So if we connect this vertex to the two foci right here, let's say we have here this connection right here. Okay, we connect that, and then also this connection right here. Okay, so what do you think is the total length of these two lines? So as you can see, it is 2a, right? Because this distance right here is the same as this distance right here. Okay, so if we transfer it to here, if we transfer this distance to here, so if we add them all up, then you will get 2a. So actually very cool. Okay, so all of the distance here, the constant distance, is actually 2a. Okay, so what can we get from this finding? Okay, so we can actually relate a, b, and c. By the way, the c here is the distance from the focus right here to the intersection of our axes. So this is what you call the C. Okay, so this is C right here. Okay, so now, so to the center of our ellipse. Okay, so now if we select this point right here, which is also known as the co-vertex, if we select that point and we connect the foci to there, so this is, we can say that these two distances are equal, right? So 2a is divided by 2. Therefore, we can say that this distance right here is actually a, right? Because 2a divided by 2, that would be a. So we also have B here for the semi-minor axis, and we have C here. So we have a right triangle here. So therefore, the Pythagorean relationship between these three variables is a squared is equal to b squared plus c squared. Okay, so we will use this in problems later. So yeah, so there is actually a derivation for the equation, a standard form of an ellipse in the module. So I will no longer be um, doing the derivation here because it is kind of long. So we will jump right in to the standard form. So if you're curious about the derivation, then you can go to the module and check it out. Okay, so for this, the standard form of the ellipse actually varies a little bit depending on the orientation of the major axis. So if we take a look at this illustration right here, as you can see, the major axis is along the y, right? So this will still be the A, and the B will be on the x-axis already. So how does that affect our standard form? Okay, so the standard form for this particular orientation of the major axis is actually x squared all over a squared plus y squared, y squared all over b squared is equal to 1. Now, if this is the orientation, if this is the orientation of our major axis, then it will be modified a little bit. So we will have x squared all over b squared plus y squared all over a squared is equal to 1. So, okay, so A right here is on the y-axis. So there you have it. That is the slight change that we need to take into account always. So we need to remember this because we might forget this. So we will answer the wrong answers in different problems. Okay, so that's it for the introduction of the ellipse and its basic parts. So we will solve different examples in the next videos. So thank you for watching, and we'll see you in the next videos.